We would like to pay our respect and acknowledge the traditional custodians of Dharawal country, the land that we are discussing in this video. We'd also like to pay our respects to elders past, present, and those emerging. We'd also like to extend our respect to Aboriginal and Torres Strait Islander people viewing this video. As of 2021, transport activities nationally account for 24.6% of all energy use, with road use accounting for 80.5% of that, 1,144.7 petajoules. Roads overall account for 19.77% of all energy used in Australia. Let's have a look at some statistics and figure out how much of that large number the Illawarra is responsible for. The Australian Bureau of Statistics stated in their 2020 survey of motor vehicle use that the average passenger vehicle fuel economy was 11.1 litres per 100 kilometres, with a ratio of total diesel to petrol consumption of approximately 1 to 4. The European Automobile Manufacturers Association stated that energy per litre of diesel to be 36.9 megajoules per litre and petrol to be 33.7 megajoules per litre. From these data points, we can calculate how much total fuel is consumed in the Illawarra on an average workday and how much energy this equates to. To determine the total fuel used, we can divide our total kilometres by 100 and multiply by our fuel economy, resulting in a massive 1,181,817 litres of fuel. We then need to calculate the average energy of a litre of fuel by summing the products of each fuel type's energy content and proportion of total consumption, and dividing by 100, averaging to 34.34 megajoules per litre. We can then determine the total energy required for transportation by multiplying the two values, giving us a total of 40.59 terajoules of energy used per average workday. While the total energy used for transport is an important number, it is equally, if not more important, to look at how that energy is actually being used, i.e., how much of it is actually being used to move people around versus wasted through the process. To determine how much energy is discarded in the process of transportation, we need two more data points: efficiency of the average passenger vehicle in terms of useful energy harnessed, and the mass fraction of people versus the vehicles they are using. Researchers from the German Jordanian University and the University of Newcastle found tank-to-wheel efficiencies of 14 to 33% for petrol vehicles and 28 to 42% for diesel vehicles. For these calculations, we're going to assume an overall efficiency of 30%. The Australian Bureau of Statistics 2013 Australian Health Survey found that in 2013, the average male mass was 85.9 kilos and average female mass to be 71.1 kilos. Assuming a 50-50 ratio between sexes, we get an average human mass of 78.5 kilos. According to the Department of Infrastructure and Regional Development, the average gross vehicle mass of a passenger vehicle in 2013 was approximately 2,200 kilos. We first need to determine the useful energy gained from an arbitrary quantity of fuel simply by multiplying 1 by our tank-to-wheel efficiency of 30%. This tells us straight away that 70% of the energy in the fuel we are using is being discarded as waste product to the environment. We then need to calculate the mass fraction of the driver of a vehicle. For this, we assume an average payload capacity of 500 kilos and subtract this from our gross vehicle mass. We'll then divide our value for the average human weight by the gross vehicle mass minus payload plus the average human weight, giving us a mass fraction of 4.4% for the driver of a vehicle. We can then determine the overall fraction of energy that is used to transport the driver by multiplying the tank-to-wheel efficiency with the mass fraction, giving us an overall value of 1.3%. Applying this value to the daily energy used for transport in the Illawarra shows us that, at a conservative estimate, we are wasting 40.05 terajoules of energy, or 98.7% of the energy we put in, on transport per day. This is an astonishing waste of energy and resources, especially given the environmental, health, and societal costs that are associated with fossil fuels. The use of internal combustion engines as our primary means of transport brings many issues. The most prominent at present is the production of a range of greenhouse gases, toxic byproducts, and hazardous particulates. Under artificial conditions, the products of pure carbon hydrogen hydrocarbon combustion are only carbon dioxide and water, the first being a major contributor to the long-term greenhouse effect, while the latter is readily taken into the existing hydrological cycle. Unfortunately, passenger vehicles operate in normal atmosphere and use fuel that is not purely made up of carbon and hydrogen. As a result, internal combustion engines also produce a wide range of additional pollutants, the most common being methane, nitrous oxides, carbon monoxide, non-methane volatile organic compounds, sulfur oxides, and particulates. The enormous quantity of fuel used in the Illawarra produces an enormous quantity of emissions. Using data from the Department of Infrastructure, Transport, Regional Development, Communication and the Arts Australian Transport Assessment and Planning Guidelines, we are able to calculate the quantities of these emissions. First, we can find the weighted average emissions based on our previous diesel to petrol consumption ratio and apply this to each emission. We can then calculate the total emissions per day by multiplying the average by the quantity of fuel consumed.
A concept map can be used to look at how things are connected. As our topic is on reducing Wollongong's emissions associated with transport, we've put the word transport at the top, making it the overarching word, connecting everything together. The concepts that are in the blue boxes are connected through a colour-coded system. Yellow means forms of, as in cars and buses are both forms of transport. Orange is requires, as in both cars and buses require roads in order to drive, or how health requires money to maintain through either doctors or dentist services. Red means creates, as in maintenance creates jobs through mechanics, or buses create jobs through a necessity of having a driver. And finally, purple is affects, as in how pollution can negatively affect our health. This concept map has helped us to see how our possible changes could impact the wider community or flow-on effects, as all of these concepts are interconnected by many factors and are essential to each other.
A proposed way to reduce fossil fuel emissions is by increasing the frequency and efficiency of current public transport operations. By increasing the number of buses on the roads, Wollongong will need to implement bus-only lanes and limit the amount of street parking, as well as integrating smart technology to enhance the efficiency. By increasing the number of buses on the roads around Wollongong, alongside implementing bus-only lanes and limiting on-street parking in the CBD, is a comprehensive approach that is designed at reducing fossil fuel consumption and greenhouse gas emissions. Public transport, like buses, are more energy efficient than individual cars, especially when they carry multiple passengers. Increasing the number of buses on the roads allows more passengers to be transported collectively, maximising the efficiency of the public transport system. By consolidating trips and reducing the number of individual car journeys, this approach decreases overall fossil fuel consumption and greenhouse gas emissions. By reducing the number of cars on the road, there is more efficient traffic flow, which reduces the congestion and minimises idling time, leading to lower fuel consumption and emissions. Implementing bus-only lanes prioritises buses, enabling them to move more freely and reduce delays caused by traffic congestion. By limiting on-street parking, road capacity is optimised, further improving traffic flow and reducing emissions associated with idling and stop-and-go traffic. Promotion of the public transport industry can influence commuter decisions. Encouraging the use of public transport over private vehicles is imperative in this. Providing incentives such as convenient bus services, discounted fares, and improving infrastructure, this encourages more people to choose buses as their mode of transport. This also reduces the number of single occupancy cars, leading to decreased fuel consumption and greenhouse gas emissions. Along with implementing bus-only lanes and limiting on-street parking, integrating smart technology to enhance the efficiency of buses on the roads in Wollongong can significantly contribute to reducing fossil fuel usage and greenhouse gas emissions by improving user experience. Real-time tracking systems provide accurate information about bus locations and schedules, the arrival times as well as departure times. By doing this, you're enabling passengers to make more informed decisions about their travel. By equipping buses with GPS and integrating them into a centralized management system like an app, passengers can access real-time information about bus arrival times and departure times. This encourages more people to use buses and reducing the number of single occupancy cars, thereby lowering the fossil fuels and emissions.
So in this part we'll be talking about a quantitative treatment of one of the elements proposed earlier in the video. So we proposed that implementing more buses on the roads can be efficient way to reduce the use of fossil fuels. So from Group Transport Australia, it was found that one fully sized coach can carry up to 100 passengers, which is equivalent to 20 average sized passenger cars. From the graph, it shows that the average fuel consumption of different types of vehicles. We will only focus on the passenger vehicles and buses. So the average fuel consumption on passenger cars is 11.1 liters per 100 kilometers, and for buses is 27.8 liters per 100 kilometers, which is way bigger than a car. So in this part, we will calculate how much fossil fuel can be avoided annually if 20 passenger cars were to take the bus. From the previous slide, the average fuel consumption per passenger vehicle was found to be 11.1 liters per 100 kilometers, although the average fuel consumption per bus is found to be 27.8 liters per 100 kilometers. The average kilometers traveled per passenger vehicle annually was found to be 11,100 kilometers, and the average kilometers traveled per bus annually was found to be 24,600 kilometers. From that, we can calculate the total fuel consumption for each annually, and it was found to be for passenger cars to be 1,232 liters of fossil fuels consumed annually per car and 6,839 liters per bus. Taking that into account, that one fully sized coach can fit the same amount of passengers of 20 cars. The fuel consumption of 20 cars is 24,642 liters. From this, we can calculate how much fuel can be saved, which is found to be 17,803 liters.
79% of Wollongong's inhabitants drive around via individual cars. This means that the majority of the population is choosing a transport option that emits the most CO2 and demands the most out of the environment. This highlights humans' disrespect for energy. By limiting this mode of transport, people have to look around at more communal and more eco-friendly options of transport. Our team aims to create a society that is not only more sustainable but conscious of the choices they make and how they might impact the environment. Public transport can help to make the individual more aware of the collective situation, focusing on how they are actually going to be transported from location to location and the energy that is used. The Indigenous belief system is centred around country. This is the belief that the land humans occupy is not only sacred but living and connected to all aspects of life. This means that from the water that humans drink and use, to the earth that our buildings sit atop, to the minerals deep below our earth's surfaces, a level of respect is essential. To show respect for energy, our team has reduced potential emissions in the Wollongong community via transport.